Remember that the function y equals e to the x has an inverse of y equals ln of x. So you're going to use all of the same laws of logs, but with the ln. So remember, the ln is the natural log. Okay, the base is an e. So what is each expression written as a single natural logarithm? So for a, ln of 7 plus 2 ln of 5. Same rules apply. If you have a number in front, it's the exponent. So we're going to rewrite this as ln of 7 plus ln of 5 squared, because we're just bringing that exponent up. Now 5 squared, we're going to change to 25. So ln of 7 plus ln of 25. Because we're adding, we're really going to multiply the 7 and the 25. So we have the ln of 175. Okay, same idea with b. Our numbers in front go as our exponents. So we have the ln of x cubed minus the ln of 2x squared. So that 2 in front, that's the exponent that's going to both the 2 and the x. So we have the ln of x cubed minus the ln of 4x squared. Because we're subtracting, we're going to divide. So ln of x cubed over 4x squared. And then we can simplify this. We can subtract our exponents. So we get the ln of x over 4. Okay, and then the last one, we get ln of x cubed plus ln of y squared plus ln of 5. Since everything is being added, we're going to multiply it all. So we're going to have the ln of 5x cubed y squared. So now we're just going to look at some more. So again, numbers in front go as exponents. So I have ln of m to the 5th minus the ln of n cubed. And then we're going to divide since we're subtracting. So we have the ln of m to the 5th over n cubed. Okay, in the second one, we're going to have ln of a minus ln of b squared plus, and I'm going to change this to the ln of the cubed root of c. Because I can change it to c to the 1/3, but then I have to change 1/3 into a radical anyway. And now, anything that's being added or that's positive is going to be in the top. That's getting multiplied. Anything that's negative is going to be in the bottom. So in the top, I have the a, and I have the cubed root of c. In the bottom, I have the b squared. And the last one, ln of 3 minus the ln of 3 to the 5th. So I'm actually going to do 3 to the 5th, and that's going to give me 243. So ln of 243. And then I'm going to divide. So the ln of 3 over 243. And that's going to be the ln of 1 over 81. For these examples, we're going to solve each equation. So just like we did with logs, we want to condense the natural log into a single natural log first, and then we want to convert it to exponential form. The main thing that we need to remember is that the base of an ln is e. So for a, ln is already isolated, so we're just going to change this to exponential. So the base is e, so e squared equals x. So we have that as our exact answer, and then our approximate is what we get from putting it in the calculator. So 7.39. So both of these are answers. One is exact, one is approximate. Okay, in the second one, we have two ln's, so we're going to combine them using our properties and condense them into a single natural log. So since I'm adding, I'm going to multiply these two together. So ln of 2x times 3. So this is going to be the ln of 6x equals 2. And now I'm going to convert it to an exponential. So e squared equals 6x divided by 6. So my exact answer is going to be e squared over 6. My approximate answer is going to be 1.23. Okay, if we look at a couple more, so the first one, the ln's already isolated, so we're just going to change it to an exponential. So e to the 6th equals 3x, and we're going to divide by 3. So our exact answer is x equals e to the 6th over 3. The approximate answer is going to be 134.48. Okay, and again, the second one has the ln already isolated, so we're just going to change it to exponential form. So e to the 4th equals x minus 1 over 2. So we're going to multiply both sides by 2. So we get 2 e to the 4th equals x minus 1. And then we're going to add 1 to both sides. So my exact answer would be 2 e to the 4th plus 1. My approximate answer is going to be 110.2. Okay, and then the last one, I don't have the ln isolated, so I can do one of two things. You can apply that 2 in front as an exponent, and then you would square the entirety of 2x squared, so it would become 4x to the 4th, or you can divide it out. Okay, so easier way is just to divide it. So now we get the ln of 2x squared equals 1/2, and now we're going to switch this to exponential form. So e to the 1/2 equals 2x squared. So we're going to divide by 2, and then take the square root. So my exact answer, because we're taking the square root, it's going to be plus or minus. So you can leave this as e to the 1/2 over 2. That's fine. You could actually simplify that and write it differently because you technically have a radical on the bottom. You can rationalize. For right now, that's fine. Okay, and then if we approximate it, it'll be plus or minus 0.91.